In this question from JEST 2022, we are given an ideal gas of 1 mole. It undergoes a thermodynamic cycle which involves 3 processes. The first one is isobaric process. From A to B we have isobaric process. In isobaric process, pressure is constant. From B to C we have isochoric process. The volume is constant in isochoric process. Thirdly, we have adiabatic process from C to A. Now at A, the temperature of gas is given to be T. We are asked to find the change in internal energy of the gas in units of RT when the system goes from A to B. So when the system goes from A to B, the process is isobaric process, which means P is constant. P is equal to constant. Now the gas given is ideal gas, which means it obeys ideal gas law, which is PV is equal to nRT. From here we can say P is equal to nRT by V. This is equal to constant. Now N and R is already constant. N is given to be 1 mole. R is universal gas constant. Therefore we can write T by V is constant. From here we can write TA by VA is equal to TB by VB. TB by VB. Now TA is given to be T. At A the temperature is T. VA is equal to V. From the PV diagram you can see that. Equal to TB is given to be, TB is to be found out. VB is given to be 8V. Therefore we have TB is equal to T times 8V divided by V, which is equal to 8T. Therefore the change in temperature here when we go from A to B is 8T TB minus TA, which is equal to 8T minus T, which is equal to 7T. In the case of an ideal gas, internal energy is given to be F by 2 nRT. Here F is the degree of freedom. Change in internal energy is equal to F by 2 nR delta T. In our case, delta T is coming out to be 7T. Therefore we have delta U is equal to F by 2. N is 1 mole. Here it is given that it is 1 mole times R times delta T is 7T. Therefore we have delta U is equal to F by 2 times 7 times RT. Now we need the change in internal energy in units of RT. Therefore we have delta U is equal to F by 2, 7F by 2 in units of RT. Now we have to substitute the value of F. F is degree of freedom. To find degree of freedom we can use the relation between adiabatic index and degree of freedom. Gamma is equal to 1 plus 2 by F. This is the relation between degree of freedom and adiabatic index. Adiabatic index gamma is equal to Cp by Cv. Now for an adiabatic process of an ideal gas, PV raised to gamma is equal to constant. Therefore we can write PCVC raised to gamma is equal to PAVA raised to gamma. Because this process from C to A, it is given to be adiabatic process. Now substitute the values of PC, VC, PA and VA. Then we will get PC is equal to P, VC is equal to 8V, PA is equal to 32P, and VA is equal to VA is V. Therefore we can write P times 8V raised to gamma is equal to 32P times V raised to gamma. This implies P and P gets cancelled. 8V divided by V raised to gamma is equal to 32, which means 8 raised to gamma is equal to 32, or 2 raised to 3 raised to gamma is equal to 2 raised to 5, which implies 3 gamma is equal to 5, or gamma is equal to 5 by 3. From here we can say gamma is equal to 1 plus 2 by f. So from here 5 by 3 is equal to 1 plus 2 by f, which means 2 by 3 is equal to 2 by f. 2f is equal to 6, f is equal to 3. Now substitute the value of f in delta u. Delta u is equal to 7f by 2, which is 7 times f is 3. 7 times 3 divided by 2, this is equal to 10.5. In units of RT, delta u is coming out to be 10.5, but in the answer key it is 17.5. I don't know why it is 17.5. If you know, let me know in the comments. The answer that I am getting is 10.5.